Right. We're moving on to the next question. This one comes from Steve. Thank you very much, Steve, for sending us this awesome question. It's a very, very short question. So Steve's question reads as follows. It says the diagram in figure 2 shows the graph of f of x. So let's write that down. It shows the graph of f of x equals to negative x cubed plus 6x squared minus 9x, right? Now, t has an x coordinate at 2. T is this point. It's a point on the graph. Its x value is 2. Do we know the y value? No. All right. What can we do if we had to figure out the corresponding y value? Just in case in future they wanted you to find the complete point t, if you've got an x and you've got the equation of the graph, you can just simply substitute this x in the defining equation. It's going to spit back the corresponding y value, which is going to give you what the corresponding y value of t is going to be in this case. So that's not a big problem. Okay, cool. Now, they continue further on and say to us here, find the gradient of the tangent to the curve at t. So they're asking us for the gradient. Now, let's remind grade 12s that there are two types of gradients. There's what we call average gradient, okay? This is the gradient that is known by grade 11s. That's the one of saying gradient is change in y over change in x. And then there's another gradient which is called instantaneous gradient. That's gradient at an instant, like instant porridge. It's gradient now, not tomorrow, not between points that are too far. It is gradient at one point. And we find that by doing what? By finding the derivative and substituting our x with whatever the x value is in that point. So you can clearly see that grade 11s would never answer this question because they have one point. They will obviously scream and fight and shout, where's the other point? How do I find gradient at one point? This is why this is a grade 12 concept. We are asking for gradient at a point. This is found by the derivative. Okay, so how do you do that? Let's go back and derive and then substitute. So we are definitely here. This is basically where we are. So I'm going to find the derivative of this cubic. When you derive its exponent times coefficient, you're going to get negative 3x squared. 6 times 2 gives you a 12. You're going to get positive 12x. And the derivative of negative 9x is just going to give us negative 9. So we want the gradient. This is the formula for the gradient at any x value. We want it when x is 2. Why? Because at t, x is 2. So you're going to just substitute 2 everywhere where you see x squared plus 12 into 2, of course, minus 9. Calculator is an instrument, not a monument, so you people should use it, right? Particularly if you feel like you might make mistakes with signs and those kinds of things. So we've got negative 3 into, we've got an x value of 2 because we're looking for the gradient when x is 2 squared plus 12, all right? Plus 12 into 2, close brackets, and then the last thing that you're dealing with here is minus 9, then tenfold us, we end up with a gradient of 3. So the gradient is definitely going to be 3, and that will be the solution to this very beautiful question. All right, cool. So I hope this has actually helped you to understand and see what is happening in terms of calculus-related questions. You can be able to connect with finding a cubic function, factorizing it, finding the turning points, and drawing the graph. And also, how do you find the gradient at a point?